So, welcome. It's the lecture on microservices. It's the sixth lecture this term. We are in winter term 21-22. And we did a really good start and progress last week, and we were able to actually go through the whole scenario that is depicted up here. So it is someone working in the warehouse who has this screen here. He selects to do the store tasks because new products have been arrived. Then he gets an overview. So this time it's Peter of the warehouse, the pallets within the warehouse. Initially, it should be empty. And so he selects the add button, says, okay, store a new pallet. B1, okay, it needs to be a little bit smaller. It's a BO1, it's the pallet ID, red shoes are on that, 10 pairs or boxes, and it's stored in shelf 42. And so he presses OK. And at that point of time, the browser does a post request to the shop, to the warehouse backend, and sends all the data that Peter has entered. And the warehouse is going to react on this by internally storing some new information about the current state. And we did not actually do it this way, but I have worked on this example a little bit. So we were just storing actually the information that was handed to us, and we are fine with it. And actually, for simple cases, this is enough. For more complex cases, you would like to set up an object-oriented data structure that represents the current state of your warehouse. And you might have an object representing the product, red shoes, and an object for each pallet that you actually have. And actually, when Peter does another pallet, BO2, this is another step, then you get another pallet that is connected to the same product. And if there is a pallet number 3 with blue jeans on it, you get a new product object and a pallet object attached to that one, and so on and so on. And if you have this object-oriented data structure and you want to know, oh, where would I find red shoes, you could actually look up the red shoe product object and then ask for all the pallets that are attached to it, and then for the location of those pallets. And so this is one way you could actually model it. And we did implement it a little bit differently, but in complex cases, or we would actually, well, we were just saying, okay, it's enough to have this. I go into details how we were implementing that, but this is the ideal idea that you could have. And if you have such a complex data structure, these objects here actually need to live in your database. So we would have to extend our database, our Mongo database, with the data type pallets, or with a collection of pallets, with a collection of warehouse products, and have these connections implemented. And we did a shortcut when we were implementing the warehouse, but we will this week go on with the shop. And so I go back to the initial example. Once the warehouse has actually stored this information, it is sending out an event, and I use orange color for those events that are from backend to another backend. And this event goes from the warehouse to the Microshop backend, and it says, and then the Microshop creates its own data structure, which is in our case just an object for the product. And we will actually implement this or start to implement this today. Before I actually go there, I still have to explain a little bit, how is this async await magic thing actually working in TypeScript, and why is this very important, and how do you handle that? And I actually have prepared that a lot, and it's awfully complex. And let me start our system. We start the Cypress one, and we start the micro warehouse front end. Come on, it should have, no? Okay. Warehouse front end, yeah, npm start. That should do the job. And have npm start on the backend. And you guy, yeah. Let's stop that. Let's stop that. It was the warehouse front end spec. That is the test we are today having a look at first. Oh, this is the front end coming up. Cool. It's working. This is the I have added a second test we will have a discussion on today. So we first have a look at this test. And that one should not yet work. Yeah, it does not work. Oh, yes, it works. No, it does not work. Because I did not yet start the backend. npm start. So I have 3 programs running. I have the Cypress test running, or the Cypress environment running. I have the front end of the warehouse running, or the Angular service that deals with the front end, and the back end, which is running in this window. And it's so small you can't see anything. It's a horror. This is going to become 5 of these things soon. And I'm sorry about that. So now the test should actually do its job. Yeah, here we are. Yeah, and this is all like we have these. This a little bit enlarged. No. This a little bit enlarged. No. I need to make this small to make this big. This is okay. Sorry for having this in the small font. Yeah, so it's better. It's the thing that we have achieved. So when I actually press this button here and then enter data, yeah, why not? 50, come on, there. Then something happens in the background. And what actually happens is we send this command to the warehouse, and then things happen. And let's have a look at what's actually happening in the warehouse backend. And that is what we do. And actually, we are going to look at when this warehouse page is shown to the user with the list of pallets. This list of pallets is actually retrieved from our backend. You still know that, and therefore we use this get query thing. And is this true? Yeah. And I want to have a look at how this get query works. And actually, I need to use a somewhat smaller font, otherwise you can't see enough. And I hope that you can you actually still read that? So what is the selected word, Lucas? Put it in the stack, in the chat. It's the way. So yeah, get query, great, thank you. And I'm sorry for this small font. So there's this mysterious async keyword here, and there is an await keyword here, and we have no idea why. And I'm already in the service. Let's go in the controller. So when the browser request comes to the backend, will hit this controller thing here. Okay, we need to have the full line. And the controller is actually analyzing the URL that is being sent by the browser and decipher it and look at its contents. And this is done by the nest environment for us. And then finally, the get query operation or method is called. and the thing that is after the slash is passed as the key parameter, and it says, oh, I'm going to deliver a promise back. And that's a weird thing. And then it says, does some console log here. I have added this for debugging purposes and for showing it to you. And then it says, do app service get query. There's no await here. It should have an await, but to explain the details of the technique of how this actually works, this as an await, I just omitted it here, and you will see this through the lecture. This is complicated stuff, and actually, it's really hard to explain that. And actually, during the explanation, the next 20 minutes, stay calm. If you do not really get it, it's not that much a problem. At the end of this, we will learn a rule of thumb. When you follow that one, it's all very easy. And just to understand why this rule of thumb is so important, you go through these details. And if you say, okay, I do not want to bother with, then there is an easy workaround that we will show at the end. Okay. But still, this get query here again returns another promise and then does this console log up. So how is this actually working at runtime? And let's have this here, and this is here. So when we start the backend, the Nest application, it actually does a call to app.listen. This is in main TS. Do you want to see that, or do you believe that? Let's have a look. It is in main TS in the warehouse backend. It has, this is how the warehouse backend is started. It actually calls an operation that is called bootstrap. Here again, this async is here, and it does a Nest factory create app module and await, and we are not going into that one because this is library code I'm not familiar with. Then it does this app enable course, that is that we do cross origin responsibility or whatever this is good for, such that the Angular application can talk to our warehouse backend. And then it does this app listen, and again an await for some reason. The listen itself, it actually does something like, so usually the backend sits there and does nothing. It only reacts to requests coming in from some browsers. And therefore, the Nest application, the backend, is living in, we call it an event loop. And this is this while true, and it has a queue where new requests from browsers are developed or are delivered to. And this is like a postbox, like an inbox, and you put your request in that one, and then there is someone behind the counter who is taking this thing from the inbox, working on that, and when it's done, it comes back with the answer, and then it looks again in this inbox, and if there have been new requests meanwhile, they are already in this inbox, so the guy at the counter takes the next letter from the inbox and handles it and so on. And as soon as the guy comes back to the counter and the inbox is empty, he says, I get a coffee, and waits for the next request coming in. And this is how graphical user interfaces basically work. So the Angular application has a similar event loop, where it waits for the user to click on something. And actually, when the Angular application, the front end, sends a request to the back end, it says, okay, I've sent out this letter. I'm waiting for the response, and the response is going to be delivered to the event queue of Angular. where also your mouse clicks and your key typing is delivered to. And there is this handle. So, and the backend, the NAS backend, and we are here at the backend, has again this loop where it waits for requests coming in. So as soon as such a request comes in, and let's put this request in here for the get query, this one is delivered to the event queue, and then this loop here starts to execute that one. So get query itself says, oh, I'm going to be asynchronous, and I'm going to deliver a promise. And whenever this happens, what you actually do is you create a new project promise object. Let's say 901. This is a promise object. And it has a bunch of properties. And the first thing that this promise object has is a resolve operation. I'm not sure whether this is the actual implementation, but let's do a then operation here. It also has an error operation that is attached to it, and it has something that is a value where the response is delivered. And it actually also stores something like a parent promise that is going to be delivered to. However, this is the very first promise in this setting, so we just stop here. And the resolve field actually is going to get the code of the operation that is going to be called. And actually, it contains these two lines of code until another asynchronous operation is called. So we just put the code in here, and I just do this here a little bit. Okay, and perhaps it should be like this. And the code is actually copied into this POTB object or a handler to that code. So in TypeScript, you can actually have variables or data fields that contain operation or code. That's just the same thing, and you can actually put it there. And the part that is handled as soon as this is completed is the then code, and I actually put that one here and edit here. Come on. Yeah, if I put that in, that's so hard. We do not have enough space. Come on. Let's have it this way. Sorry, this will take a time. Okay, but I kind of do. And actually, the return result is going to be modified, but let's go on and then do it later. So this is what the TypeScript compiler actually does for you when it sees this adding things, and you do not need to handle this yourself, but this is internal mechanism that actually handles. So, and then it says, okay, please, event queue, could you call resolve? So it does a job into the event queue, and then this while true loop, the guy working here wakes up and says, okay, oh yeah, I'm doing that, and starts to execute this operation. And the content of this is the things that we have copied here. Okay, and we can actually put this a little bit smaller and have this a little bit larger to see what's going on. So it executes this thing here, and it should actually put console log app controller get query called with some key to the console. And actually, that's what you see somewhere here. App controller get query called with key palette. So this is the very first console.log that has been issued, and you can actually see it. We were running this call when we were running our Cypress test, and so we can actually have a look whether that what I'm explaining to you is working in reality too. And I'm sorry for this, that it's so awfully complicated. So it's here. And then we say, okay, let's execute this one here. And the app service get query operation is again app service get query. Let's go there. Is an asynchronous operation. So it again creates or returns a promise. So what we need to do is we need to create a new promise. This is promise 902, and its resolve operation is all this code up to here. Let's put it here. Yeehaw. And the then code is everything behind that. It's going down up to here. Okay. And there's still no value yet, but this one actually now has something which I would call a parent. I have no idea how they really call it, but they have something like that. And we have been called from promise 901, and we are promise 902. And then this resolve call is actually put into the event queue. Actually, we have consumed this from the event queue. We are currently executing. And then it's called, but we can actually also say, oh, we stay in this one here and go on with the execution of the 902 resolve. So when we execute this, we are actually doing a 902 resolve thing. Let's close this one here. And so we get the code from 902 resolve. Here we are. And put it here. So what does it say? It says, oh, app service get query start. Hey, yeah, we are still in sync with the actual implementation. Yeah, cool. And it says, so we have executed this one. Here. And I'm sorry for me, why, I'm not sure. Next year I will have a better explanation. This year it's so complicated. It's actually, I have digged into this very hard because it was so confusing, and was listening to a lot of videos on internet about this topic, and that is what I get with currently. Okay, and here we have an await. This will become interesting soon. However, we again call an operation which is asynchronous, and so we create a new promise. So it's the 902 thing. We just copy it, and we put this here. So this is now 903, and it's a model builder get by tag. And I know that the first two lines are going to the then part. 903, or the parent is 902. I put this one here, and I will learn to do this better, and the rest of it is going to be the then part, which is much smaller here, and yeah, okay. So, and then we call it, of course. So it's, come, let's just copy that one. So actually this should be 902. Sorry for that. Copy, paste. This is now 903. And the code that we are going to execute is here from the then part. Yeehaw, great. And we start to execute this. So let's have a greater than. And so this says builder service get called. Builder service by tag called. Yeah, great. It works like, that's pretty much what we expected. And the thing that's unexpected is coming soon, actually just now. We are going to execute this one here, which is again an asynchronous request. And build event model was this database collection where our build event were living in, and then we do a find on that one. And this is an operation that actually sends a request from our Nest service to the Atlas MongoDB living somewhere in the cloud. And so this is the thing that does actually another post or whatever the mechanism actually is, sends a message over the internet, waits for the return, and this is actually a thing that will need a long time. All the steps that we have done here, we were able to execute directly, no problem. This call will actually need time. And actually, Node.js or TypeScript is a single-threaded language. So there's only one event loop and only one event handled at a time. That's not true, actually. These single-threaded application uses library functions which are implemented in C, and those are actually handled in parallel. So this find operation is going to be executed on another CPU of your computer, and your first CPU can go on with the TypeScript stuff. So this find here is implemented in a way that you do not actually call the resolve thing directly, but it says, no, oh, this is going to be handled by someone else, and we will go on. So we still have to create another promise object. It's 904, and then we are actually done. It's not getting more complicated, but still complicated enough. And well, the content of this is something with the who. This thing is going to be there. And the then part is, I have no idea, it's actually empty for now. And the parent is 903, and here we are. So this is actually handled now the very first time in parallel. And so the execution of this thing is going to continue without waiting for the result. Well, actually, here it says await. Yes, we are going to wait for this, but this waiting is done within this promise here. And the execution of this one says, okay, wait for the response. As soon as the response comes, execute the then part. Until then, just go on with your business. So this operation here is going to return. And this thing here is going to deliver the hash 903, the promise object, instead of the value, the list of palettes we are actually looking for, because that one is not yet there. It says, yeah, I have created a promise. We are going to handle this. Here is your number. Wait for it. Oh, and this one says, oh yeah, I need this result now. I'm going to wait for this. So this operation is actually going, okay, I'm leaving here, and this one is returning. And so it puts sharp 902 here, where it has been called. Yeah, and this one says, yeah, cool. Oh, yeah, put this 902 into the result here. And then go on. But actually we are at the end of this. And in the result, no, we are not. because there is no await here, we can actually go on and do the next step. It has no await here. And he says, oh yeah, it's fine. So we go for 901 and execute the other thing. Is this true? I hope so. So it does 901 dot then. Let's see. And so it does app controller get query done. App controller get query done. Hey, wicked. So we were doing these calls down the stack, and then in the third level on our stack, it said, yeah, we have to wait. So we are popping up the operations, and we come up to this 901 thing. And let's have again a look at the full. This is in the app controller. No, it's in the app service. I'm not sure. It's 901. It's the top level. And yeah, it says app controller. So we're starting here. Did this one? Did this call? This call was going down all the road, and then was popping up again without actually delivering a result, because we are still waiting for this. And this one says, yeah, it's okay for me if I just get a promise. I do not have an await here. So I can actually execute this one and execute this one, and I'm ready there. This operation is asynchronous. So our handle event thing here, that one will again have an await. That one will actually say, okay, thank you for the results for this promising. I will wait until this one is actually finished to deliver value to my customer. And we are done. So this operation here is now executed. And it's really tricky to set it up in a way where execution of these things is a little bit different than what you usually would expect. And yeah, let's see what's going on. So we have executed this one. We are done. We have executed everything here. We are done. Cool. And so there we wait for, hey, we get another coffee in this event queue, and we are actually happy with our life and go on and have these things doing. One point in time, this 904 promise is going to deliver a value. And we get a list of pallets, P1 and P2, with all the data in it, delivered into our value. And then 904 promise is called. We put 904 then actually into the resolve has been implemented, has been executed in parallel by some other mechanism. We put the 904 then here. Put that one here, put that one here, and have it here. So the 904 then, that one was actually empty. That's not good. What it actually does is something like a return statement is actually in here. And actually what it does, the return is, it actually does a return value at the end. So the value that has been delivered by the resolve operation has been stored in the value field of this promise. And then the return says, yeah, I would like to return this value. But actually, we cannot do a simple return here because, well, the stack where this resolve has been initiated is gone. We were terminating the operation that was calling this. So what we actually do is we say, we have a parent, 903, and that one has a value, and we assign our own value to that one. And then we do our 903 dot then. We call the then operation of the upper thing. Because we say, oh yeah, here's the value, you can continue. Well, actually, I think this one is again an event that is going to the event queue and then pulled from the event queue, but I'm not sure about that one. And so finally, what we do is we execute this code. Yeah. So the value is this one. So it's the value of 904. Yeah. And we put that into 903 value. 903. Where's 903? Here's 903 value. We put it there. And then we call the then operation of 903, which is this one here. So we copy this one. Put a 903 here. Get rid of that one. Copy the code that we have stored there, and it says, oh, the next thing they should put on the console is builder service get by tech is done. No, let's give it. So here it is. There's a question. Why is app controller get query done in the console empty? Nothing with very good question. Thank you for that. Get query done is the controller. Yeah. This was this one here. And this one does JSON stringify, come on, of the result thing. The result thing is a promise. And so this promise at this point in time, when I execute that, does not yet have a value. So that one is not shown because that one is still going to be computed. And the resolve and the then fields are somehow inner fields and they are not printed to the console. So JSON stringify, they are somehow hidden from JSON stringify. And so you just says, yeah, the result is still empty, and therefore it prints an empty thing here. So it's not yet resolved. That's the point here. And we are going to change this soon, and then you will see, oh yeah, if it has something in it, then it will actually show something to you. Okay, thank you for the question. That was a good one. And we are here, and we have executed this one. Yeah, so it's done now. Here, and the empty line is actually from the app controller console log here. That one actually has a \n by it, because I was thinking, yeah, then there comes a new request, but it's not the correct order currently, and that's actually the caveat, the thing that you need to be aware of. Be aware of, or you have to look out for when, if you do not handle other weight correctly, then things may happen in an order you do not expect, and you will access data that's not really there, and these are the problems that we are dealing with today. Okay, we are almost done. Sorry for that. It again says return list. So the list is still P1, P2. And return is done again with these things of operations. So we actually go for the 902 promise. And get the code from the 902 promise, which is this one, the then code, please. Okay, and execute that one. And then it says, okay, construct another object, put P1, P2 into the list thing here, print app service get query is at the end, app service get query is at the end, return the answer. And this is again the then part of this, so return is again, yeah, put this value one step up. And there we actually put the answer thing into the value of the 901 promise. here we are. And then the return says call the then operation of 901. So we go here. That's that. 901.then. And that then part is just these things here. And so we get an app controller get query done with result. App get query called with key palette. So where's the result actually? App controller get query done. I have no idea. Oh no, that one has already been executed. Yeah, we have done that before. So we are not. So it's going actually up the hill one more step, and then we are done with the whole thing. So sorry for this is still weird stuff, and I don't get it really, and I really had a hard time to prepare this for this lecture and in a way that I can actually explain to you. And what you finally learn from all this. Now let's actually get rid of this one. Don't save. Don't save. Go all the way. So what's really happening, or a rule of thumb, what you should do is you start implementing it and you do not yet have something like async, so you just go the way. You do not put actually something in here. You call app service get query, okay. You implement that one, and you don't have that one at the beginning. And then you call this one here, and you're dealing with that, it's all fine. And you call that one here, and then initially it doesn't have an async await here. And then you say, oh, I need to call find. And this is an operation provided by Mongoose for you. It's not your implementation. And that one says, oh, I'm asynchronously. I'm async. I'm delivering you a promise, not a real value. And then you said, oh no, I really want the real value. Do not deliver something else to me. And then so you put an await in front of the async call. And the simple rule of thumb is every time you do a call an asynchronous operation, put an await in front of it. And then in order to be allowed to put an await here, you need to put an async here. And this has the effect that at the place where this one is called, this is now an operation that is asynchronously. And so at the place where this is called, you put an await in front of it. All the time, put an await in front of an async operation call. And so this one becomes async. Cool. And so now we look for calls of the get query operation, and this one is here. We put an await in front of it, and therefore we put an async here. And because we are lucky, the people that were implementing Nest were ready to put an await at their side too, and so now we are done. And if you do it this way, consequently, anytime you call an operation that delivers a promise, put an await in front of it, make yourself async, and everybody who calls you needs to do the same thing. And if you do it everywhere, then these things are executed in the order that you would expect. Let's store that one here, and that one should have restarted this. And so if I now go for my test and just rerun it, yeehaw, and go back for our output here. So this is still the service running, and here it was started, and it gets an app service start, query start. It gets a controller get query, service get query, builder service get by tag. Builder service get by tag is done now. app service get query and app controller get query is done, and the result object that was empty last time now contains actual data. And here is the thing. So it was actually doing this nested calls, method operation calls, just the way we were expected, and it delivers a result, and we are happy with living that. So that's the rule of thumb. If you do not want to go into the details, how these promises are handled, put an await of it in front of it. All the time, you are safe. And your application is running smoothly, and it's actually still doing things in parallel. You're fine, it's working great. And as an exercise, you might go through the execution with all the e-waves, with the stack and promise creation and stuff, to really get an idea where the difference is between these things, or you just forget about it. Okay.
Maybe you want to show the one way you edit so the actual object will be evaluated.
Where we did that?
Yeah, which of these e-waves is the actual one?
The important one.
Yeah.
And it was the one in front of the controller. So if there's not the await here, this thing is going to deliver a promise, and we are going on directly. If you put an await here, this one is going to deliver a promise, but we wait until the value is actually available before we go on with this code here. And then the await actually unpacks the promise and puts the value into the result, and not the promise itself. That's the real point here. Yeah. So, yeah, I had a hard time to figure this out, so fine. Okay. Ooh, and sorry, I had the feeling we need to go through it, because otherwise, so why do I do this with the await thing? Come on, Albert, tell me. And then you will finally run into some problem, and you say, okay, I have no idea what's happening in my code. Okay. I don't need that one any longer. Yeah, let's kill it. So let's go for something completely different. We still have half an hour left. That's cool. I'm not sure whether we actually will make it to a reasonable homework this week, but let's just proceed with the assignment. Yeah. So no, it's much easier. I have implemented a new test for the shop backend. So we are now starting with the shop backend. Yeah. And so we'll have a look at our scenario. And it says our warehouse shall set up some data, and then it shall send an event to our Microsoft backend. And the Microsoft backend shall react with this kind of information. Or store these things. Okay, let's do that. I have actually prepared it. And what I did do, let's see this one here. I was going to the Microsoft page, and I created the Microsoft backend, and I was doing this with Nest. It's a backend. It's a Nest application. Nest create or new. I do not know the command. Nest new Microsoft backend executed in the Microsoft directory creates the Microsoft backend directory with all these Nest content that you usually have. And then I went to the package.json and did change the start by adding a -- watch, because I wanted that to be uniform in all my applications. And I was going to the source and then to the main TS. And I was actually, did I copy this thing? No. I changed this line of code and said, okay, the port 3000 is already used by our warehouse Nest application. So I need another port, and I put this in 3100 for no good reason. 3001 would be good too. And to just see that I'm running on a different port than usual, I put a console log here, and we'll actually have this one. So currently I do not need this thing here running anymore. And this was the front end of the shop. We could have let it there. No, it's too hard to read. Come on, C, stop it, and just close the window. Yeah, so it's now the Cypress thing and this warehouse backend. I stopped the warehouse backend. And let's go up a little bit and up a little bit, and let's go for the micro shop, and let's go for the micro shop backend. Yeah, and then do an npm start here. So that one should now start the npm backend on port 3100. Hey, cool, it's running. So, and then, well, actually the scenario says the warehouse is going to send an event to the microshop. And I have had quite a discussion with there's a message on the chat. So the listen function is an asynchronous one, like find. So we would put the await there as well. I have no idea why they do that. Yeah, it's, but it's actually, yeah, it's great.
Yeah, it's because the listen starts the actual application, and the initialization of everything should be done before
Or you actually handle something.
Correct.
Well, actually, you put an await in front of it because it says it's async. That's it. Full stop. No reason about it. So, for testing purposes, to send this orange event to the Microshop needs a lot of preparation in the warehouse stuff. And I would like to, well, test this more directly. And therefore, I set up a new Cypress test who's actually sending this orange thing to the Microshop backend. That's the basic idea. It's just another test, and that's fine. You can do that. So I have a new test, which is the shop backend test. And this one is already running. Hopefully. And it says, no, I can't do that. It's not working. With it, the shop backend is not working. And actually, let's just re-execute it. Now it's working. Oh, that's great. And actually, I would like to go to the source code. Opening IDE. That should have worked. And so it should be here now. And here it is. Here's the test, the shop backend test. I put that one just to the very left and close all the other stuff. The main TS we have seen. Okay. This is now the new Cypress test that has the task to send this orange thing to our backend, our shop backend. And what I do is with it, the shop backend, just to see if it's running. And I do just a side with it, HTTP localhost 3100. And 3100 is the port of our Nest application for the shop. And this is going to deliver something like hello world. So where's this hello world coming from? I'll close them all. Microservices, Backend, Source, App, Controller. Here we are. Put that one small, put that one, close it. The app controller is, so this is the get hello world that is generated by Nest for you automatically. If you just get to localhost 3100 and nothing, no parameters in the URL, this one is called, and this does get hello, and this says hello course, and I implement that, then it is recompiled and restarted. And if I go for my test and rerun the test, it says hello course. Here we are. Yeah, it's connected. It's fine. It does what we expect. Okay. Then the backend operation says, okay, read that the shop database. We do not really need to do that. So yeah, once the test is executed, our shop backend populates the database with stuff. And to rerun the test, we would like to have an empty one. And so yeah, we were discussing how to achieve this. And so I said, okay, I want a special controller operation where the test can read that the database, and I have implemented that one. Let's have a look how this one is working. App controller. So this is the reset thing. It's a get operation, and it does an app service get reset. And I think we need that one too again. So that is all the same thing that we have had before. And my database is in a model builder service. And that one was actually more or less a copy of the things that we have created for the warehouse. And well, actually what you do is you say, I want a nest generate modules/builder, and this generates the models builder thing here, and the build module, and yeah, that one, this file here. And then you do a nest generate service modules/builder, and that one will create that one here. And this is basically the same things that we did for the warehouse. You do it for the shop backend too. And then you add this Mongoose stuff. You do a nest install Mongoose and some more of these things in order to set these things up. And yeah, did I forget something? I probably forget something. But just revisit the lectures for the warehouse, and then you see what you need to do here. And then you need schema, and for some reason, there's the build event schema. This is a one-to-one copy from the warehouse, and there is some more. No. The product schema. That is a new thing because I want a second collection in my database for this product objects. I want the real objects, not just the events. And I wanted to see how to achieve this. And that's actually going to become awfully complex. We still have 50 minutes. We are going to make it. I love it. So the app controller reset operation, get reset, does an app service get reset. Look for this is asynchronous because it's going to deal with the database, so put an await in front of it. And the app service get reset, that is an operation you need to implement. I actually can put this a bit larger again. Yeah, why not? This does a model builder service reset. I was thinking about changing, so do I really need this extra hop or not? I have no idea. We did it in the first one. I think it's still a good idea. Let's see. So it's the model builder server is where our database actually handles. So we go there. It's still asynchronous because it's handling with it. This does this dot clear. This is just the same thing that we have had in the warehouse. But actually we go look at it and see there is an await in front of it because you put an await everywhere where it says it's asynchronously. And that one does a products model delete many and a build event model delete many. It put both things there and does an await in front of each of these just for safety reasons. Okay.
Do you return the second one?
I have no idea. It was in the old code. It's copy paste. Put it away. Okay. Yeah. Okay, fine for me. So yeah, so this is this clear here. So I just do empty and then I actually initialize my database with some initial data for the same reasons we did it in the warehouse. And I put this into the reset here. And it does handle product stored. This is actually the handling of these things, and we will have a look at that one soon. So yeah, this is going to happen, and it was very handy for testing purposes to do it in this way, but I will have a look at it soon. So after doing the reset thing, my test is then actually sending this event. So post a product stored event. Product stored is history. This is now actually this thing here. Product stored 1204. This one is sent to my thing. So yeah, let's have a look. It does a Cypress. This is the Cypress handle to actually get access to every operations of my test environment. And it does not a visit. Visit is actually saying, oh, please give me an HTML page to be shown to my user. Request is do it behind the theme. And that one does a post because we push actually information into the shop backend. And I have a new endpoint for this. This is the event thing here. And we will have a look at it soon. And the object that I'm sending is this one. It has an event type that is product stored. The block ID is black socks because that is said here. No, that's different. I have to change that one. So this is another product that we have in our database. I think I'm initializing it with rubber boots, and now we get some socks here. And it's still 1204. That's not a good time after all. Let's have a look. Change this. Oh, let's have 11.4. 11.4, is this good? Yeah, 11.4 is very good. And I have no tags yet because I don't think I need them. And I have a payload, or the tags are actually going to be added by the backend itself. So it's not my business. Actually, I should be able to omit it, but there were some error messages where and then I tried to fix it and I put this here. I'm not sure whether this really fixed the problem or the problem is still there. I have no idea. Okay, and then there comes some payload, which says, oh, here is black socks and its amount is 10. Okay. So this request is again this asynchronously executed. And so we need to wait for it to respond and then to handle that. However, I did not find out how to put an async here. Cypress uses its own inner event loop similar to Angular, and it has chainable things which wrap just the promise inside and do things I have no idea of. And the thing said, no, here you actually hand this then operation yourself. You put it in here manually. So this is a request and another parameter, no, this is doing the request, and then you add a then code by calling a then operation on this chainable thing, and then you get response, the value that has been delivered by the post request, in this parameter in here. And so this is a lambda code thing that you do, and that is the code that you want to be executed as soon as the value is delivered to your test. Yeah, that's cool. And then actually Cypress will actually do this await stuff for you, and then everything is fine. And then we'll handle this synchronously. And what we do is we test whether the result is what we expected. There comes back a product and it says it's 10 black socks. Okay. How is this actually? If I store this, it's going to be to run again, and it says no, there's a problem here. Yeah, I know what it is. That's a later one. Let's first have a look how is this handled? We go to the app controller, go for this event thing here. So if it has /event in the URL, this is the operation that is going to be called. And the thing that we push with the post request in the body is going to be delivered into this event parameter here. So there is a complex object living in this here, which is of type build event from our schema. The build event is declared in this build event schema. Okay. And then we do an await app service handle event and do a try catch around it to have to see whether something is going wrong. This is always a good idea to have this in the controller area. Otherwise, something weird is going to be back to your client. So what we do is we call handle event of the app service, usual way, and that one actually says, okay, I'm ready to handle all kinds of events, and currently there's only product stored, and so I do, and if the event type is product stored, I call that operation. If there's another event type, this is going to be extended soon, so I do demultiplexing of event types here, and we will have to discuss this, but we will discuss this next week, whether this is a good idea or not. And we will discuss REST calls in comparison to this idea next week, yeah, or sometime. So finally, we say, hey, database builder, handler, can you actually do this now, please? And have a handle product stored event here. And here comes now the magic. So what do we do? I was actually doing a lot of things here. I was and this is now pretty much over-engineered. And I'm not sure whether this is really good. And I have to get you an understanding for what's actually going on. I actually have to revisit the shop. So if you have a warehouse and a shop backend that actually send each other events, you need to deal with all kinds of tricky situations. When the warehouse tries to send the product stored event and the shop is just not running currently because it doesn't restart because you have sent some bug fix or patch something or update it to a new version, then this message cannot be delivered. So your warehouse needs to do something which is called cache right behind cache. So if I'm not yet able to send this message, I'm going to send it again later. when you are up and running again. And due to this mechanism, it may really easily happen that the warehouse says, oh, did I actually, were I successful to deliver this event to the shop? Or was there an error? Perhaps it's a good idea to send this event again. So the warehouse may, for safety reasons, send you a similar event multiple times. This is a standard problem when you have communication between two programs, that the delivery is unreliable and you need to do error handling. And so at the receiver side, expect or be ready to receive an event twice. And so to be sure that my shop backend is able to deal with multiple with events that are delivered multiple times, I actually did that in my test. And so I need to change this time because we have changed this to 1104. And I just want to send exactly the same message again. Repeat the post without a change. And here we go. And so now it is working again. So we visit the shop, we reset the database, we post the product, and that one works. We repeat the post, and then we say, oh, please ignore this. And a little bit later, we will send a different request. Let's have a look at the code, which is 1205. And that one says, oh yeah, it's later. So let's have this at 1105. Here. Okay, we're in fine. And then I actually want to say, okay, this is another palette of black socks. Please add the initial amount, 10, and the new amount, and store that you have 42 now. And to get this running, you really need to do a lot of tricks at the backend side. And actually, I was fumbling a lot yesterday in preparation of this lecture, or actually I did it on Saturday. My weekends are always microservice lecture preparation. To do this in a single mongoose database request. And I didn't succeed. I knew I need two requests, but probably because I'm not smart enough. I didn't find the right operation. Might be possible, but I was not able to achieve this. And therefore, I need two requests. And actually what I do is I do store a store event, finally. And let's have a look at that one. And the store event says, okay, there's an event coming in. Do I already have this, or is this actually a new event? And therefore, I do a find one with, this is a Mongo operation where you have a pattern object that you are looking for. And I look for any event stored in my build event collection that has a field block ID with the value that is the same as the int. So I already have an event for black socks, yes or no. And I access this one. And if there is one, I get this in the previous event. If this is the very first time I add black socks to my product stored black socks to my event store, its previous event will be null, so this find one will not deliver nothing. And then I can actually say, okay, then I create an event within my collection and store this, and I'm done. Cool. If there is a previous event, I look for the time that is delivered for the old event. And if the time of the new event is really greater than the old event time, I say, oh yeah, here's an update, execute it. And I actually push this information into my database, and I do a find one and update. I look up the old thing and put the new thing there. and that's what I would want to have. Okay, and yeah, it's hard. I'm sorry. So, and then I deliver back true, or yes, this is something, it's actually a new event that should be handled, or false for no, I have already done this. And what we do afterwards, that should be, should be here. So we have tried to store the event. If that is a success, yes, this is an event that is new that should be handled, then we put one this object to be created on the logic side of our thing, and I have this new collection for that, which is the store product collection. And in order to have a store product collection, your builder module needs to have this mongoose module for feature. You need to have the event store. This is similar to what we have had in the warehouse. And you need to have the products collection, which is something that I have added, and you need a product schema. Let's have a look at that one, which is just saying, yeah, a product that has the product name, an amount time, and a price, and that one is optional. That one will come later. And then you do this product schema, you import this, all very similar to what we did to the warehouse. Just repeat these exercise and then you get it. And so we do on store success. Yeah, please handle it. We create the information that we want to store into our and name this a product patch. We will discuss this next week. And say, oh yeah, we have a product which has block IDs. This is black socks, which has an amount. It has an amount time. Price is going to come later. And then we do a store product with this product patch. So we do an entry in this collection of Microshop product. Yeah. And that one is yet a simple one that is very similar to the one we have had before. It does a one and update. The pattern that we are looking for is just a product with this product with black socks as its ID or as its product name. And then this is a magic thing. It says, oh, this thing should have already an amount field, and I want that this one is incremented. It is so the amount is going to, the new amount is added to the old amount. We do a plus operation here, and that was a lot of Google working to find out how to do this in a single step. If you do a find first, then do the computation at the memory level, and then you do a write afterwards. You again need something like a transaction in order to make that really work. We are actually in a transaction, but I was so proud to find a solution that does it in a single request, and that is usually the better way. And you set the amount time to the amount has been changed the last time. At this one, we actually don't need that anymore. It's just for debugging purposes. I wanted to use that in order to demultiplex to have multiple updates. If the theme palette comes in and here are 10 boxes, here are 10 boxes, it's 1204, it's 1204. You only want to add it one time. But now we actually do this is a repetition already in the event store, so we do not need to have it here any longer, but hey, come on. Having it double is a good idea. I do an app search too. So if it's new, this increment says, okay, it's initially 0 and just does store the real value. And I want this new that says, please deliver the new database content. By default, they deliver the old the find one and update delivers the old database content because, well, the new one is that you already provide, you actually know about. But yeah, come on. I found this very handy. And I do a console log and we have a look at that. And if there's an error and these kinds of stuff. Okay. It's almost done. 1336, and I'm sorry, this is really a complicated thing, and we will have to have more discussion on that and why this is a good idea to have it. But the very first thing is be ready for receiving the same event multiple times, and so check for I already have got this, and I do not handle it again, or it's a new one. And this is a scheme that I have to come up with how to do that. And so we do a store event, and this one tells us, yes, this is new or not. If it is new, we store the product and we update the amount of black socks that we currently have, and then we are done. If store success is fails, I do not update the amount of products, but I just deliver what's currently in my database. So I do a find one on the block ID and do this into the new product thing, and then I do a return of new product. So, and then there's 2 more lines of code that need to be handled or explained, and then we are done for today. And the first line of code is this start session here. And I'm not really sure whether I'm doing this correctly. I was Googling that. What I really want is starting a database transaction. So we are actually doing multiple operations on our database. We are asking for, do we have an old event? Then we update the event. And the third step is updating the product information. And these 3 operations are run one after the other on our database. And there are all these awaits around and living and everywhere. So they are running in the background somehow. And while this is, yet the next event may come in. There are multiple pickers working in our database, and they are sending me one product update after the other, product stored event after the other, in a very soon thing. So, and while I'm still handling the first product stored for black socks, already the next one may come in. And then these 2 operations may be, or the 3 steps of these operations may be step 1 of operation 1, step 1 of operation of event 2, and they might be intertwined. And that's a very bad thing, because we will actually may end up with an inconsistent state. And therefore we wrap this into a transaction. And then the database says, yeah, so now it is executed in isolation. All these 3 things are executed, 3 steps, without another transaction going on in parallel. Yeah, hopefully. Actually, I did not really test this. And the rule of thumb in software engineering, if you could not test it, it's probably not working. I have no idea. So this is what I took from my database lectures and how you should handle that, and from the documentation. But I have not yet means to really test this. So what we need to do now is set up a test, a Cypress test, that sends us, some 1,000 requests within some millisecond. And then we see whether these are handled, the parallel execution is handled correctly. And actually, sorry, this is beyond my expertise. I'm not able really to do that. And we have another course for this. There is a course called Web Engineering. That is a master course. And that one is going to be held again in 2 years. We have had it last summer term, sorry. And this is going to be held by Peter Horn, who is actually a chief programmer, a software developer, and owner of how's the enterprise named? The Ticket Toaster. Ticket Toaster is an enterprise that sells tickets for rock concerts and festivals via the internet. And those Ticket Toaster people are able to handle or to sell some 50,000 tickets for a concert within 5 seconds or 5 minutes. And they are able to handle this enormous amount of parallel requests. So they say, oh, there's this great concert of your famous rock star next week, and ticket sales start at 12 o'clock on Monday, and at 12:04 they have sold 40,000 tickets for that concert. And if you are able to do this correctly, then you really understood how to do database transaction handling. So learn from this guy. It's not my expertise. I'm not really able to teach this to you, and I hope I did this right. I'm going to ask Peter Horn as soon as I see him, is this okay or not? And the other thing that you really will learn from Peter is having a counter for all the products that you have, all your black socks that you have at their thing, at a single place, that's a very bad idea. That is to handle this counter, you need transactions, and transactions are slow. They are blocking each other, and don't do that. So for high performance things, you need a different concept and a different organization of your internal database. And however, I'm not the guy going to teach it to you, but you need to go for this other course. Sorry for that. But hey, go for that other course. And then they will actually show you how to make a high performance backend. Okay. We are over time, and I actually would like to stop to this now. You guys, Max and Sebastian, you think we can have this as a homework? No way? No way? Too much?
Yeah, maybe they could generate a short backend.
Yeah, this database stuff is bad.
Stuff, communication that you need to explain it again.
Yeah, okay, I see so. So, Sebastian tells, so this database stuff is so weird, please take more time to explain it in detail. So what we ask you to is just set up the shop backend, all these Nest stuff, set up the controller with all these things here, and perhaps it's okay to have the two database collections, yeah, and just forget about these transaction stuff and the demultiplexing, just store the events there. And then we will revisit and we do just, that's an easy one. Just send the event one time. Just send one event and store it, and do not deal with the problem of having it received multiple times yet, but we will do that next week. Yeah, that's a good idea. Yeah, that should work. That should really make it easier for you. Okay, that's it. So Max is going to set up the detailed description of the assignment in the Discord. Because and then we will see how you deal with this until Thursday. Have fun with it, and I hope to see you next Monday, and then we will have dig into this in more detail and get it running, hopefully. Thank you. Bye. Have fun.